Okay, so there's the, so literal equation means equation with more than one variable, or letters in the place of constants. I mean, we'll, just to give you, this may not actually clarify much, but I'll still show it. We'll get to, when we get to straight lines, we will get to y equals mx plus b. You've probably seen that. Okay, the variables are x and y, right? M and b are constants. We may not know them when we start the problem, but they're not variables. They have some kind of fixed value, not like the variables, which can change, right? That's what we mean by letters in the place of constants. But what does it matter to us when we're doing this thing? Not much, right? In the end, they all look like variables to us when we're solving, right? So these would be variables. Right? These would be constants. Constants meaning they don't change. So the book, I'm trying to show a little bit the way the book does this. And I've never seen it done quite like this. I don't think it's quite wrong. In fact, it kind of helps me to try to explain this in a way like I do usually explain, but it's not really what they're trying to get at. We are trying to solve this equation right here, right, which is ax plus b equals c for x. By doing, again, solving still means isolate the variable on one side by doing operations to both sides. Now, if looking at that kind of thing, it gets confusing because you're looking at all these letters, then try to look at the equation, which is, let's just say, structurally looks exactly the same. If I was going to solve 2x plus 5 equals 11, what would I have done as a first step? I would subtract 5, right? So what am I going to do with ax plus b equals c? I'm going to subtract the b. Right? The fact that I don't know what b is doesn't matter. It's still the right thing to do to isolate, subtract b from both sides. Right? And for our 2x plus 5 equals 11, now we have 2x equals 6. Now, on the left, when I subtract b, right, on the left-hand side, b's cancel. B plus negative b cancel. On the right, c minus b, you can't put together. At this point, you kind of do look at them like terms. They're not the same variable raised to the same power. So all you can really do is write c minus b. Just write c minus b. Can't do anything more. What would I do on the right? 2x equals 6. Yeah, now I'm going to divide by the number which is multiplying times x. So I divide 2x by 2, which means I have to divide 6 by 2. And I get x equals 3. Right? On this problem here, I'm going to divide both sides by a. And the a's will cancel, which isolated the x. And on the right, c minus b divided by a, that's the answer. You can't put any of it together. That's the answer. Now, I think what they are trying to show with this is that at the beginning of this, if we looked at the ax plus b equals c and compared it to 2x plus 5 equals 11, we would have said that in this equation on the right, it must be that the a value is represented by 2, the b value was represented by a 5, and the c value was represented by an 11. So once I come up with this formula right here, I could just plug in the values for a, b, and c to solve. 11 minus 5 divided by 2. So we kind of create a formula for solving this thing by doing that. Because I've never seen it quite presented that way, but I often do use here's a an equation that only has one variable and a bunch of constants we do know, and we'll just try to follow the same steps. Don't be confused by the fact that you're looking at a bunch of letters. You're still doing the same steps, right? The same properties of equality to both sides. Right? That was their working out of it. So I use mine more as just an example because you're more comfortable solving the other one. They're using it to come up with a formula, x equals c minus b over a, so that then they can plug in and solve 3. In the end, we really don't do that very much. We do this a lot. I mean, you know, in the real world, you're not given many equations with one variable and told to solve. You know, you're given equations with many variables, or maybe you're given many equations with many variables, and you have to solve. So the one thing you got to keep in mind whenever you've got these letters that you really don't know their value is you can't divide by 0. So if you ever see one of those letters in a denominator, you have to say that that letter can't equal 0. If you go back to their example right here, that's what this here says. Assume that the a does not equal 0 because, look at, the a is in the denominator. What happens when you divide by 0? Put it in your calculator. Divide, put in, say 5 divided by 0. What does the calculator say? Error. You know, just think of it. Dividing as a process is, you know, saying to yourself something like, how many smaller units of a size 0 could I get into a bigger unit? I'm dividing up a pizza into pieces, every one of which has 0 area. How many pieces would I get if I divided a pizza into smaller size pieces? They're so small they have 0 area. How many pieces would you get out of it? Doesn't make sense, right? I mean, it doesn't. That's why you get an error. You can't divide by 0. So we have to get used to seeing that kind of thing. A does not equal 0. It's kind of like nails on the blackboard, you know, for math. No divide by 0. So you try to solve that one for x. Good question. Solve for x. So again, let's try to look at it compared to a problem that only had one variable, the variable that we're solving for. You know, what would we have done as a first step? In this problem on the right, what would you have done as the first step? Subtract 12. So what will you do here?
Subtract A.
Subtract A. Okay, so here I've got 12 minus 5x equals -3. I subtract 12 from both sides, and I get -5x equals -15. Okay, over here, if I subtract a from both sides, it looks like -bx equals c minus a. And about half of you didn't include the minus in front of the b. That's where you were getting wrong. You had everything else right, but you had a positive b. So when you divided by a positive b. That was incorrect. Okay, and then on the right, what would I do next? Divide by -5, right? Divide -5, divide -5. And that x equals 3. Okay, here I divide by -b. Divide by -b. Right? X equals c minus a divided by -b. Which is honestly not, sometimes my b's look like 6. But that's probably not the way you would see that in the book. They would do something to get rid of the minus. What do we usually do to get rid of a negative? You multiply by -1. Now, if I multiply the if I multiply the denominator by -1, I got to multiply the numerator by -1. You can't just do that in the bottom, right? We do that to equations, and we can do it to both sides. But if I multiply this one, Trinity,
Oh, yes.
okay? If I multiply the denominator, because it's going to turn that into a positive b, then I got to do the same thing here. Now, the denominator definitely turns positive. What happens to the numerator when I multiply c minus a times -1? Jonathan? It'd be -c plus a, or you could just write it as a minus c. Right? It just reverses the order of subtraction. Because again, what happens when you reverse order of subtraction? 3 minus 1, 1 minus 3, you get the opposite. So normally we would do that. Switch the order. Like that. Well, I'm sorry. She's just going to have to wait. All right, you're not going to teach the whole class up to now. But we all wait. Okay? Okay. Let's try and, I was going to show you this one. Because this is exactly the kind of problem that gives us the most trouble when we do these. Because we're solving for x. But notice that the x is in two terms. And they're actually not even on the same side of the equal sign. So, in order to try to figure out what we'll do to that one, what would we do to this one here? If I was solving 11x equals 6x plus 20, what would we have done? Not quite. What would we do? There's no combining of like terms to do on the same side. We want to get the variable terms together. Which one would we usually move? Abby? You would probably subtract 6x, right? So this on this side you would have minus 6x, and then that would be 11 minus 6x. I'm going to write this as an intermediate step. 11 minus 6x equals 20, which means that 5x equals 20. Okay, if I'm going to do the same thing on the literal equation on the left, then what am I doing? Subtract the bx, right? Just like we subtracted the 6x here, let's subtract the bx here. Minus bx, minus bx. Okay, on the right, the bx's cancel. What does it look like on the left? Ax minus bx. Look at what I did here, the reason why I put that intermediate step. Right? A minus b in parentheses times x. Exactly. Right? That's what it looks like. When you combine like terms, when actually you don't know the coefficients, you need to just add or subtract those coefficients and leave them in parentheses. Okay, now we can, what will we do on the non-literal equation? 5x equals 20, we will divide by 5. So if we're doing the same thing on the left, then we get x equals 4. What will I do to the literal equation? Divide by a minus b, right? In parentheses, divide. A minus b, that's sloppy, a minus b. So the a minus b's cancel. X equals c divided by a minus b. And you can't do anything with that, right? You're done. Finished. You isolated the x on one side, whatever's on the right, that's your answer. So there will probably be a couple homework problems where you've got to deal with this. So, I mean, if you take good notes, go back to this problem and see what we did. Or watch the video. That's why we're making these videos. If you're getting stuck on a homework, don't just stop and say, I don't get it. Do something. Try to be a little resourceful. Now this question, the next example that they have in the book is they kind of say things differently here. And because we haven't really dealt with functions yet, it seems a little out of place. They did talk about functions before. But what it means is, when it says, write this equation, 3x plus 2y equals 8, so that y is a function of x, it just means solve for y, right? Then it's a literal equation, right? Because it's two variables, x and y. And we are going to solve for the y. That's what it means, to be a function of x, solve for y. So looking at this thing here, and now I'm not going to do like I did for the first few examples where I always had that other equation, which was not literal. We'll just solve this, hopefully. 3x plus 2y equals 8. And we are trying to isolate the y. So what do we need to move so that y is isolated? The 3x and the 2, right? Which would we move first? The minus, subtract 3x. Remember, it's kind of a reverse order of operations, right? We do multiply before, add, and PEMDAS. But here we do that, get rid of the additional term before we divide. So subtract 3x. Two y equals, now what are you going to do with 8 minus 3x?
It would be 8 minus 3x.
It's 8 minus 3x. I mean, you can't put them together. They're not like terms. One has the x, one doesn't. So don't try to add them, right? This can be 8 minus 3x. When we get into dealing with straight line stuff, which is like what we do next, and is like the second most important thing that we do in this class, we would probably write it like this. 2y equals negative 3x plus 8. We'd probably write the x term first. But are they the same?
Yeah.
Does it matter the order that you add things?
Yeah.
Which property says it doesn't matter the order? It's not associative. Associative is grouping. Which is the one that says order doesn't matter? Commutative. Commutative. So whether I write 8 minus 3x or negative 3x plus 8, it doesn't really matter. But I would definitely think you'd probably say 8 minus 3x at this stage. Okay. And then what's the last step? I still haven't isolated y. Divide by 2. Right. So if I divide by 2, 2y divided by 2 equals 8 minus 3x divided by 2. And if you remember, when we were doing that section on division, it was right after we did the distributive property with real numbers, and then we did the division, and it was actually on our last test. How do we simplify something like this? 2 terms in the numerator.
Oh, make up both fractions.
Okay, what would it be?
Well, just
What would the 2 fractions be?
want to be 8 over 2. Yeah, it'd be
8 over 2. Then what?
minus 3x over 2.
Minus 3x over 2, exactly. I mean, that's why we learn that stuff. Now, I can simplify that, right?
Yeah.
I can make that a 4. Y equals 4 minus 3 halves x. Right? Again, if I would have followed this one doing the same thing, it would have looked like y equals negative 3 halves x plus 4. And there's your y equals mx plus b. That's why we tend to try to have the variable term first, the x term first, because then it matches up with y equals mx plus b, which is what we'll do later. We're not doing mx plus b now. Yeah, and we'll graph that. Okay, so when it says write it so that y is a function of x, what are you going to do? Solve for y. So try to do the same thing with that one. Okay, so, people mostly did fine with this. Subtract 5x, subtract 5x. And 4y equals negative 5x plus 20. divide by 4, divide by 4. So y equals negative 5/4 x plus 20 over 4. Y equals negative 5/4 x plus 5. And, you know, when we get into talking about functions, I mean, a function, which I think you've probably seen something with this, but generally a function is something that you plug in a value for one variable so that you can calculate the value of another variable. So it really needs to be that that second variable is solved for the second variable, right? We call the variable which is in the expression on the right is called the independent variable, because you can substitute a value for x, anything you want, and then you would have to calculate the y, so it makes that the dependent variable. So that's independent, that's dependent variables. But it would answer a question. And we get into talking about functions, which I'm not sure what exactly when we do that. But just think of the word function. To function means what? To work, right? To function, to work, kind of the same thing. Generally, when you have a function, if you plug in a value for x, you should get one answer for y. It should answer a question. Like if you work at a part-time job and you make $8 an hour, you say, how much will I make if I work 20 hours? 8 times 20 is 160, right? You get an answer. A function gives you an answer to a question. It works. Right? It wouldn't be a function if it didn't give you a clear answer. In this sense, y is a function of x. It depends on what you plug in for the x. And I think somebody already mentioned this. Somebody said something about the graphing. Yeah, and because you cannot solve explicitly for either y or x. I mean, there's not like one number answer here. All you really can do is plug in a whole bunch of values for x, calculate the values for y. Those become a whole bunch of x, y points that you can plot, and then draw a line. So functions you graph. Okay, here's a geometry formula, which you are not expected to know yet, I guess. Maybe you've had it before. Have you had area of a triangle?
Yes.
So it says the area of a triangle is given by the formula A equals 1/2 BH. So that's a literal equation for us, where B is the base and H is the height. Solve that formula for the height. Right? So let me rewrite it over here. A equals 1/2 BH. So if I have to solve that for the H, that means I need to isolate the H. Well, what's with the H that I need to get rid of so that it's isolated? There's a 1/2 and there's a B.
When you minus the 1/2 first? Or is it second?
No and no. How about let's deal with the B first, right? What is going on in between the B and the H? What operation is that? It's a multiplication. So what's the inverse operation of a multiplication? Division. So divide by B. Right. First step. A over B equals 1/2 BH, and I'm going to show it right here, divided by B. Now, B over B is 1. They cancel. So now we have A over B equals 1/2 H. Again, we're solving for the H. What do I need to do to isolate? Yeah, I mean, you could think of it as a divide by in half, but remember what we would recommend is just turn it into a multiplication by multiplying by the reciprocal. If you want to get rid of, I mean, so in any case, the right step here would be multiply times 2. Right? So make it 2 times A over B equals 2 times 1/2 times H. And the 2's cancel. That's why we do it. And what's left is that H equals 2A over B. So that would make h is a function of a and h is a function of b, because it's solved for h. Okay, next step. Okay, given that formula, then it says find h when a is 64.4 and b is 14. What are they expecting us to do? Plug it in, right? This is an evaluate. In the end, this turns into the evaluates that we started on day one, right? You know, you're given an equation with some variables, and then they give it the values, you plug in. So this one turns into h equals 2 times a is 64.4 and b is 14. So somebody with a calculator, tell me what that is. How about give me 2 decimal places to the right of the decimal point? Oh, 128.8?
128.8.
Did you divide by 14?
9.2.
9.2? Okay. Right. That was a calculator. Okay, so first we solved a literal equation, and then we evaluated it. Given the values, we evaluated it. So now you're going to try to do the same thing. This time we're talking about the perimeter of a rectangle, right? A rectangle, here's the picture of the rectangle here. It's got a length and a width. What do we mean by the perimeter of a rectangle? The distance around, right? The distance around would be like start in one corner and then go, you know, all the way around, adding up the lengths. So it's L plus W plus L plus W, which is 2L plus 2W. So that's your formula. Try to take this formula, P equals 2L plus 2W, and solve it for the W. Okay, so first step, I'm trying to isolate this W right there. So what I'm going to try to peel away first.
Subtract the 2L.
Yeah, subtract the 2L. Again, it's another thing where if you divide by 2, you're not necessarily wrong. Okay, I mean, you can still be right and do that. But we would recommend move the 2L term first. So if I subtract the 2L, minus 2L. And then I have P minus 2L equals 2W. Okay, I still haven't isolated the W. Now you know, what's going on in between the 2 and the W here? It's a multiply, so you divide 2 on both sides. So W equals P minus 2L divided by 2. Now, could you simplify that? Yeah, I mean, you really could. You could say that's P over 2 minus 2L over 2, which is P over 2 minus L. That's fine. That's what Mike had. That's good. So these last couple with the triangle and with the rectangle, those are formulas, right? So that's the break point between the literal equation and a formula. So you try, okay, we already did that part. So now we're going to use this. W equals 2L. Oh, what am I doing? That's not right. P minus 2L over 2. Okay, now, so use the formula that we did on the last slide. And this is giving us the value of the perimeter, P, and the length L, find W. Right, that's your U try. Find the W for this particular rectangle right there. Okay, plug in. W equals 19.2 minus 2 times 7.2 divided by 2. Now, if you put that in the calculator, like all on one line, make sure that the numerator is in parentheses. Okay, if you don't have it in parentheses, you're not going to get the right answer. Right? If you did all of that correctly, it would have been 2.4. So if you didn't get 2.4, you probably did something wrong with the calculator. We need to figure that out.
I got 2.6. This is what I did.
2 times 7.2 is 14.4.
Okay, that makes sense.
Did the calculator do a mistake?
Yeah.
Second and third. Second and third. So 7.2 times 2 is 14.4.
Oh, I'm just blind.
Second enter brings up the last thing you typed. And you could keep doing it, it'll bring up way back. Okay. So here's I got to finish with the weather one, which says you're visiting Toronto, Canada over the weekend, and the website gives the forecast. But notice that all of the temperatures are in Celsius. So here's the equation. It's a formula, which is Celsius as a function of Fahrenheit. If we want to know what the Fahrenheit temperatures are, we need to solve that for the F, so that it's Fahrenheit as a function of Celsius, and then we'll plug in. Right? How do I solve that formula? We're trying to solve for the F, which is here. Right? What do I have to peel away? Remember, you could, if you distribute, which is not altogether wrong, you'd still have to deal with the 5/9 times F. What do we usually say we should do since we're multiplying the whole side by a fraction? Multiply by the reciprocal, right? So this is going to look like 9/5 times C equals 9/5 times 5/9 times F minus 32, right? And now all of this cancels. Now we have 9/5 C equals Fahrenheit minus 32. And we're trying to isolate the Fahrenheit. Last step? Plus 32. Fahrenheit plus 32. Right, so this Fahrenheit equals 9/5 C plus 32. So what's freezing on the Celsius scale? 0. So if you plug in 0, then 9/5 times 0 plus 32 is 32. And that's freezing on the Fahrenheit scale. What's boiling on the Celsius scale? 100. 9/5 times 100, the 5 goes into 100 20 times. 9 times 20 is 180. 180 plus 32, 212. There you go. So 212 is boiling on the Fahrenheit scale. So that formula works for us. So now it says we want to calculate what is the Fahrenheit temperature which is forecasted for the low temperature on the Saturday and Sunday. Well, those days the Celsius forecast is 14 degrees and 10 degrees. So figure out the Fahrenheit temperatures. How are you going to do that? Just plug them in. Yeah.
Can we use the second formula about the backwards issue?
Sure. She's asking, can you use the, if it was solved for the F on the right? Sure. That's symmetric property. When I was in the military and I was the weatherman, right, and I was stationed in all these countries, they all do Celsius. And usually when we have to brief the American commanders, there's foreigners in the room. So you always had to do both temperatures. And I was probably better at it before, but a lot of these, like 14 was 58 and 10 was 50. I mean, probably some decimal rounding there, you know, but you know, we didn't look it up every time, because if you do it like every day over and over again, you know what they are. Plus, I mean, like there's some of these temperatures, Celsius temperatures are what's used when you look at the weather data, like of the atmosphere. They don't use Fahrenheit temperatures. It's Celsius. So what did you get for the 14 degrees? I'm gonna put it in kind of a f of 14. That's saying, since f is a function of c, f of, when c equals 14, is 9/5 times 14 plus 32. And you, what was it again? Everybody get that? 57.2. And f of 10, 9/5 times 10 plus 32. That one ought to come out, right? That'd be 1850 degrees on the nose. That's F. Okay. I'm not going to do that. Spot the errors. Okay, what did they do wrong? If you subtract b from both sides, actually then a negative b. How about this one? Instead of what? It should have divided, right? There's a multiply going on in between those two. To divide. It should have been c over a. Okay. There is homework.